Hi, my name is Sahu, and I'm delighted to present our work on accelerating lattice-based proxy re-encryption schemes on GPUs. So, this work was conducted while I was a PhD student at New Jersey Institute of Technology, USA. This paper is a joint work with my advisor, Professor Kurt Rohloff. In this presentation, I'll be talking about proxy re-encryption schemes in depth and the key strategies and the steps that we adopted to parallelize and accelerate PRE schemes constructed on lattice-based FHE schemes. So many of you people working in the field of security and applied cryptography must be already aware of this concept of proxy encryption. So it was introduced way back in 1998 by Blaise Bleumer and Strauss. And after that, many other proxy encryption schemes have been proposed, which are more secure and they are based on various other underlying security assumptions. So to recall it briefly, so PRE is a cryptographic primitive which allows users to exchange confidential information without ever exchanging the secret keys. And that is the most interesting part about it. So to consider it further, so we can use this diagram on the right. So you can see there are two users, Alice and Bob, who wants to exchange some confidential information. And there is a third party called Polly, which is there as a proxy. And this third party Polly is the one that basically facilitates the conversion of messages from Alice to Bob. So what happens is Alice publishes some data in encrypted form to Polly, and Polly, with the help of a particular re-encryption key, which is jointly computed by Alice and Bob, it transforms the message in encrypted form from Alice to Bob. And once Bob gets that message, Bob should be in a form to decrypt that message with his own secret key. And that is all the magic about proxy encryption. So in my talk, I will be covering the following topics. So first we'll see what is proxy encryption more in depth, and we'll also analyze the security notions that go with it. Next, I'll be discussing some of the benefits of lattice-based proxy encryption schemes and why they are beneficial. Specifically, we'll see how lattice-based PRE schemes like some of the flaws in earlier proposed PRE schemes. Further, we'll also see how they stop the unwarranted rights that are acquired by the proxy. Next, we'll see some of the use cases of PRE in action, and hopefully we'll be able to justify the need for acceleration in such PRE schemes. So next we'll go through the construction of BV PRE scheme, which is our first PRE scheme, and we'll also see the parameters that go into the instantiation of such a scheme and the critical noise parameter uh, that we have to be aware of, since these are lattice based encryption schemes. They are very much dependent upon the noise growth. So we'll be taking a closer look onto that. And next we'll be discussing the extension of PRE scheme um, into ring GSW FHE scheme. And we'll also see the merits and demerits of such a PRE scheme constructed on ring GSW FHE scheme. And finally, we'll understand how to parallelize the implementation of such PRE schemes on NVIDIA GPUs. Um, To understand the GPU implementation of our PRE schemes, we describe the underlying components that constitute the critical procedures in our PRE schemes, which is mainly the re-encryption operation. So these underlying components that can be targeted for performance boost are mainly the number theoretic transforms, the bit decomposition operations, and lastly and most important of them, the relinearization operation. So after that, we'll also understand the NVIDIA architecture in brief, and we'll describe how we map our kernels to parallelize these operations. And next, we'll also see how can we leverage the CUDA streams for concurrent kernel execution. And finally, we'll discuss our experimental results and the performance improvement that we are achieving in our implementation. Thank you so much for listening so far. If this topic piques your interest, and if you want to learn more on PRE schemes or lattice based cryptography in general, or maybe you just want to learn about NVIDIA implementations, so I think you are in the right place. Please head over to the main presentation and see you at CANS 2020. Thank you.